In Class 1, Division 1 locations, the National Electrical Code, or NEC, addresses wiring methods to ensure safety and prevent explosions or fires. Specifically, Section 501.10 deals with wiring methods permitted in these hazardous areas. The question at hand pertains to the use of rigid non-metallic conduit, often abbreviated as RNC, and the requirements for its encasement in concrete. The exception mentioned regarding RNC encased in 2 inches of concrete and covered 24 inches to grade refers to a specific condition under which RNC can be used in certain Class 1, Division 1 locations. The core issue is whether the encasement requirement applies only to the portion of the RNC run within the classified area or to the entire length of the conduit run, even extending outside the classified area. According to the code, the RNC must be encased for the total length of the run, not just within the classified area. This means that if an RNC conduit enters a Class 1, Division 1 area and continues outside of it, the entire conduit, from its starting point to its ending point, must be encased in 2 inches of concrete and buried 24 inches below grade. This full encasement is necessary to maintain the integrity of the wiring system and prevent the propagation of potential hazards. The reasoning behind this requirement is multifaceted. Firstly, the classified area designation indicates a location where flammable gases, vapors, or liquids are, or may be, present in the air in sufficient quantities to produce explosive or ignitable mixtures. The presence of these hazardous substances necessitates stringent safety measures for all electrical equipment and wiring within the area. Secondly, even if a portion of the conduit run extends outside the classified area, it is still considered part of the overall electrical system serving the hazardous location. If a fault or spark were to occur within the conduit, even outside the classified zone, it could potentially ignite flammable substances that might migrate or be present in the surrounding environment. Thirdly, encasing the entire length of the RNC run provides a continuous barrier against physical damage, chemical exposure, and other environmental factors that could compromise the conduit's integrity. This is especially important in industrial settings where conduits may be subjected to harsh conditions. Fourthly, the 2-inch concrete encasement acts as a fire-resistant barrier, helping to contain any potential fire within the conduit and prevent it from spreading to adjacent areas. This is crucial in preventing a small incident from escalating into a larger conflagration. Fifthly, the 24-inch burial depth provides additional protection against mechanical damage from vehicles, equipment, or other activities that may occur above ground. This helps to ensure the long-term reliability and safety of the wiring system. Sixthly, ensuring the total length of the RNC is encased is consistent with the overall philosophy of the National Electrical Code, which prioritizes safety and risk mitigation. The code is designed to provide a comprehensive set of requirements that address all potential hazards associated with electrical installations. Seventhly, consider the practical implications of only encasing a portion of the conduit within the classified area. It would be difficult to ensure seamless transition between the encased and non-encased sections of the conduit. This could create weak points in the system that are vulnerable to damage or corrosion. Eighthly, the code mandates that all components of an electrical system in a hazardous location must be suitable for that environment. This includes not only the wiring methods but also the fittings, boxes, and other accessories. In closing, the entire RNC run ensures that all components are adequately protected. Ninthly, local regulations and interpretations may further clarify or reinforce this requirement. Electrical inspectors often have the authority to interpret the code and enforce it in a manner that best protects public safety. Therefore, it is essential to consult with local authorities to ensure compliance with all applicable regulations. Tenthly, the purpose of the concrete encasement is to prevent the propagation of explosions or fires. If the conduit is not fully encased, there is a risk that an explosion within the conduit could travel along the unencased portion and ignite flammable substances in other areas. 11thly, the 2-inch concrete encasement provides mechanical protection, preventing damage to the conduit from impacts or other physical forces. This is particularly important in industrial environments where the conduit may be exposed to heavy machinery or equipment. 12thly, the 24-inch burial depth helps to protect the conduit from temperature extremes and ultraviolet radiation, which can degrade the material over time. This ensures the long-term reliability of the wiring system. 13thly, the code requires that all electrical equipment in hazardous locations be properly grounded. The concrete encasement can help to ensure a good ground connection by providing a stable and conductive path to earth. 14thly, the National Electrical Code is regularly updated to reflect new technologies and best practices. It is important to stay current with the latest edition of the code to ensure that electrical installations are safe and compliant. 15thly, the use of RNC in hazardous locations is subject to certain limitations. The code specifies the types of RNC that are permitted for use in these areas, as well as the conditions under which they can be installed. 16thly, it is important to note that the requirements for RNC encasement may vary depending on the specific classification of the hazardous location. Class 1, Division 1 locations have the most stringent requirements, while other classes and divisions may have different rules. 17thly, the code also addresses the use of other wiring methods in hazardous locations, such as rigid metal conduits in cable systems. The choice of wiring method depends on the specific application and the requirements of the code. 18thly, in addition to the encasement requirements, the code also specifies the types of fittings and boxes that can be used with RNC in hazardous locations. These fittings and boxes must be designed to prevent the entry of flammable substances and to contain any potential explosions. 19thly, the National Electrical Code provides detailed guidelines for the installation of electrical equipment in hazardous locations. These guidelines cover a wide range of topics, including wiring methods, grounding, bonding, and overcurrent protection. 20thly, the code requires that all electrical work in hazardous locations be performed by qualified and experienced personnel. This ensures that the work is done safely and in accordance with the code. 21stly, the National Electrical Code is a complex and comprehensive document. It is essential to consult with a qualified electrical engineer or contractor to ensure that electrical installations in hazardous locations comply with all applicable requirements. 22ndly, proper planning and design are crucial for ensuring the safety and reliability of electrical systems in hazardous locations. This includes careful consideration of the classification of the area, the selection of appropriate wiring methods and equipment, and the implementation of robust safety measures. 23rdly, the National Electrical Code is not a substitute for sound engineering judgment. Electrical engineers and contractors must use their knowledge and experience to design and install electrical systems that are safe and effective. 24thly, the goal of the National Electrical Code is to protect people and property from electrical hazards. By following the code and implementing appropriate safety measures, it is possible to create safe and reliable electrical systems in even the most challenging environments. Therefore, when using RNC in Class 1, Division 1 locations, the entire length of the conduit run must be encased in 2 inches of concrete and covered 24 inches to grade to comply with code requirements and ensure safety.